Welcome to The Explainer. Today, we're tackling a seriously fascinating geographic process, mass movement. If you've ever stood near a rugged cliff or a shifting coastline and wondered, how on earth does all that land just collapse? Well, you are in exactly the right place. We're going to break down 4 specific types of mass movement, going step by step so you can spot the exact visual clues they leave behind. Okay, let's dive into this. Here is our roadmap for today. We're looking at 4 distinct processes: slumping, landslides, rockfall, and mudslides. First up, Section 1, slumping, which is all about soft material rotations. So what is slumping? Well, it's a mass movement that happens specifically on cliffs made of soft materials. Whenever you hear that word slumping, I want you to immediately picture soft, permeable earth, like clay. We're not talking about hard, jagged rocks here. And that softness, it completely dictates how the land ends up breaking apart. Let's walk through the exact steps of how this forms. It's kind of like a giant puzzle. Step 1 actually starts from above. Rainwater infiltrates the ground and completely saturates that permeable clay, making it incredibly heavy. Meanwhile, step 2 is happening down below. Ocean waves are crashing in, eroding the base of the cliff and forming what's called a wave-cut notch. So now you've got a cliff that's undercut at the bottom and super heavy at the top. This brings us to step 3. The whole thing becomes unstable, and a slip plane forms. Now, here's the absolute key to slumping. In step 4, all that heavy clay slides downward in a rotational motion. It actually moves along a curved slip plane. Finally, step 5, that slumped material just flows right out onto the beach. So what does this actually leave us with visually? The end result of slumping is a bulging toe at the base of the cliff. Because of that unique curved rotational movement we just talked about, the Earth sort of pushes out at the bottom, and it creates this very distinct rounded shape right there on the shoreline. Moving on to Section 2, landslides. Here, we're going to be looking at straight slip planes. By definition, landslides involve large sections of a cliff moving rapidly downhill along a straight slip plane made of resistant rock. Notice the big swap here from our last example. Instead of soft, squishy materials, we're dealing with resistant rock. And instead of a curved slip plane, we now have a perfectly straight one. And this brilliantly illustrates how the process works. Step 1 is pretty similar to slumping. Marine erosion forms a wave-cut notch at the base, effectively kicking the legs out from under the cliff. Then in step 2, rainwater infiltrates the rock. This adds massive weight and seriously reduces the internal cohesion. But because we're dealing with hard rock this time, step 3 looks different. A straight slip plane develops. Then, bam, step 4. The rock mass slides rapidly down the cliff face in large, solid slabs. Finally, in step 5, gravity does its thing and all that fallen material piles up right at the base of the cliff. The immediate result here is actually super interesting geologically. All of that fallen, resistant rock that piles up at the base, it acts like a temporary shield. It physically protects the rest of the cliff behind it from any further marine erosion, well, at least until the constant pounding of the waves eventually breaks it all down. So the crucial point is making sure we don't mix these two up. Let's lock this in. Slumping is always associated with soft materials and a curved slip plane. Landslides, on the flip side, are associated with resistant rock and a straight slip plane. Keeping those two differences crystal clear is literally the absolute key to mastering this whole topic. All right, Section 3, rockfall. And this one is driven by freeze-thaw weathering. A rockfall happens when fragments of rock literally break away from steep, vertical cliffs made of resistant rock, and they just fall or bounce straight down the slope. So unlike a landslide where huge slabs move together, a rockfall is all about individual rock fragments free-falling down a highly vertical face. But how exactly does a solid cliff just start shedding rocks? Well, step 1, freeze-thaw weathering starts widening existing joints and cracks in the rock face. Step 2 is basically a daily cycle. Water seeps into those tiny cracks during the day, and then it freezes when the temperature drops overnight. And as you know, when water freezes, it expands. This puts immense wedging pressure on the rock. Moving to step 3, repeated cycles of this day and night freezing and thawing severely weaken the rock structure. It's like slowly prying it apart. Step 4, eventually it's just too much. The rock fragments detach and plummet under the pure force of gravity. Finally, in step 5, all that fallen material just collects right at the foot of the cliff. The end result of all this constant shattering, is a very specific, easily recognizable landform. That pile of fallen material collects to form what we call a scree slope, or a debris pile. It's basically that steep, messy pile of loose, jagged rocks you see resting at the absolute bottom of a vertical cliff face. Let's move to our final type and see how this builds. Section 4, mudslides, which are characterized by flowing slurries. By definition, a mudslide is the rapid downhill movement of saturated soil and weak rock in the form of a flowing slurry. I want you to really think about that visual phrase, flowing slurry. Unlike those solid slabs in a landslide or the dry, bouncy fragments of a rockfall, a mudslide behaves much more like a thick, heavy, and frankly, incredibly dangerous liquid. Let's break down this final formation. Step 1 is the big trigger. Prolonged or super intense rainfall just completely saturates the loose soil and weak rock. Step 2, as that water content massively increases, the material gets heavier and totally loses its stability. Then, step 3, the slope fails suddenly. It just gives way with almost no warning at all. Step 4, that thoroughly saturated mixture of soil and water flows rapidly downhill, violently following the natural angle of the slope. And finally, step 5, all that moving material forms a huge deposit right at the base. Because this slurry flows pretty much like a liquid, the aftermath looks totally different from, say, a rockfall's jagged scree slope. A mudslide leaves behind this bulging, lobe-shaped deposit at the base. The material literally just flows out across the ground and comes to rest in this very distinct, rounded shape.
Wow. Okay, we've covered a massive amount of ground today, literally. We've looked at slumping, landslides, rockfalls, and mudslides. To wrap up this explainer, I want to test your recall a bit. Based on the 4 processes we just discussed, which mass movement requires the most prolonged or intense rainfall to trigger a sudden slope failure? Really think back to what we just covered. It's an important distinction. Thanks so much for joining me for this explainer. Keep reviewing those key differences, and as always, keep exploring.